Welcome to another stair building education series. Let's go ahead and jump right into it with our first video. Here is the next video in our series for building this particular house, the two-story house with the open floor plan. In this one we are going to go over the stairs. So let's go ahead and take that wall out so we can see it a little easier. And I kind of just want to give you an idea. I know a lot of people start with a stairway. They start with an open space. I like to show the people what it actually looks like and then take it away, so at least they kind of get an idea of what we're building here. So, and another thing I want to point out, if you are looking to build a set of stairs like this and you need a little more help, don't forget to go to our website, click on the books tab, and check out some of our stair building books. With that said, make sure that the plates run through on your bottom plates if you can. Like this, you're going to be building the wall later, but that doesn't mean that the framing plate can't run through. Nice to have this stuff running through continuous. And for those of you wondering why this plate doesn't run through, well, let's go ahead and throw the base plates in for the stairway here. And you can see that it's back about 1 3/4 inches. So here we have our base plates. They're going to need to be treated on a concrete foundation. They can be regular 2x4s, or you might not even need them. I wouldn't use these. I wouldn't use base plates on a stairway with on a wood framed floor, sheeted with plywood or OSB. Just put the stringers on top of them. And we are going to be using a plywood ledger with a line. The line is going to represent the top of the stair stringers where they connect. You'll see that here in a little bit. So we're using a 3/4 inch piece of plywood. You can always use a 2x10 or a 2x12 here. And this piece is going to represent our riser. So you're going to have to make sure that you compensate for that when you are laying out your stair stringers. Also, the plywood sheathing will need to overhang to match your stair nosing. So in this case, it's going to overhang 1 inch. And then, of course, after that, you can install your stringers. I like to install the side stringers first, and then install the ones in the middle. Now, I would like to point out one thing, and that is that the plywood sheathing here, the piece, if I was going to do something like this, I would have it go back at least 24 inches. This is too small of a piece for a stair nosing. And the reason is if you could just imagine someone stepping on this thing 25 to 50 times a day over time, since it's a small piece, it could actually loosen up because the pressure, there'd just be too much pressure on the front here. So make sure that you come back and have a piece here that's at least 24 inches. 16 inches would be the minimum, but hopefully that makes sense there. And again, we can see our stringers are nice and straight. Use a straight edge for this. Now, it's not a bad idea to put your risers in and your treads in, even your risers, but a lot of times the risers will help you straighten everything out. So I like to start by installing a riser in the middle and then line everything up. And then if everything is nice and straight, then I can go ahead and build my wall under here or install the rest of my risers. But if you build your wall, nail the blocks in, and the stringers can't move, and then you find out you have to move one of these stringers, it needs to come up a little bit or go down a little bit, that's not going to be very easy to do. So here you can see why we didn't have this plate run through, and it's back a little bit, and that's because of our riser and our nosing. We have a 1 inch nosing and a 3/4 inch riser. So this right here needs to be back at least 1 3/4 inches from the front of the wall here. We also have a 1x4 spacer in between the stringer and the wall. That's so that we could slide the drywall down instead of notching around each one of these. Definitely benefit. And if you're going to be installing a skirt board for the stairs, make sure that you use a 2x4 instead of a 1x4 if you're going to be using a 3/4 inch skirt board. Now, when I say that, I've seen some thin skirt boards before where they go in and the skirt board's about 1/4 inch. And if that's the case, you're not going to need very much here. So allow for the drywall, 1/2-inch drywall, plus the skirt board if necessary, whatever those dimensions are going to be, and then give yourself an extra 1/4 of an inch or 1/8 of an inch so that you can actually, the stuff will actually fit. And take a look at the top, and something like this, you could toenail from 2 nails on each side, or you can go to the back and put a couple of nails in from the back of the plywood, or you could always use a ledger. And if you do get our stair book, I recommend getting the double stair book package for the straight set of stairs, because that's going to provide you with different methods for laying out the top of the stair stringer and the bottom where it connects to either the upper floor or the lower floor. Next up on the list will be the wall here. Once the stringers are installed, you can just simply measure the height of the wall and then build it accordingly. It's difficult to do this before the stairs are in. You can get out your math calculator and figure it out, knock yourself out, but why bother? Run the plate through. When you build your stairs, that'd be the good time to build this wall. And then install your blocks and backing accordingly. And I like to let the top plates run through so that I can nail my backing to it. And again, you can do whatever you want. That's just a little secret here that I've done. And you just need one plate to run through at least. But I like to run both of them through, get some nice nailing for the backing. Our blocks, this will help keep on a longer stairway. If you have a wall and some blocks, this will add some nice structural support and stabilize the stairway a little better. I have seen long stairs move if there isn't a wall underneath them and you can't nail it to a wall. Here you're going to be able to nail the stringers to each one of the wall framing studs on each side of the stringers, and that's also going to help stabilize it. Put our risers on, and we're using 3/4 inch plywood for our risers and our treads, and here you can see the overhang 1 inch nosing. And there you can see why we had to set the stairs back a little bit to have the step line up with the edge of the wall. That's usually how the architect draws it in. We have our 1 inch overhang on the floor sheathing, and that is it for this video. Here is a video on concrete testing you might be interested in. Not this kind of concrete testing, but this kind of concrete testing, where they will mix a variety of different concrete mixtures with different amounts of cement, gravel, sand, and water, and then let it dry for a specific period of time. And then put it into a machine that is going to put a specific amount of pressure on this particular object until it fails. And then use that information to build a variety of different things, including your home. Here is a video that is kind of a challenge, and hopefully it will help some of you. In the United States, we can get lumber in a variety of different sizes, but a little while ago, an individual asked if I could build a stairway entirely out of 2x4. And they said that that's the largest piece of lumber they can get in their country. And I didn't ask what country it was in. I do know that someone emailed me from Israel one time, and they were having a problem. I think a 2x8 was the largest board they could get. So if you know what country that is, feel free to share it in the comment area. But I'm going to go ahead and get started. And again, entirely out of 2x4, and you can use screws or nails to attach everything together. And to give you some measurements here, 7-inch risers, 10.5-inch wide treads. If you want to leave an 1/8 of an inch gap between everything, then the risers can be a little taller and the treads can be a little wider. And what I'm going to do is take the stairway apart and then put it back together. So it's just going to be a process. I know it's a lot of people, when they're doing how-to videos or how-to books, they just show you from a blank spot, maybe just the concrete here, and then they build it. But I think it's better to tear it apart and put it back together. And again, with these videos, it doesn't take long to do. So let's tear this thing apart. So it'll give you an idea of what you're actually going to be building when you put it together. Take the risers out, and then we can pull this down here. So you can see in this video here, I'm actually going to do this a little different. I'm building the sides up in this one, but when I put it back together, I'm going to be doing one step at a time. So you can do it this way here if you just reverse the process, or you can do it this way. So we're going to start with our bottom board here, and then put in our braces, and then we're going to put our riser in, and then our tread. So we're just going to kind of work our way up. In the other one, if you remember, we didn't put our risers and treads on. We built the side of the stairway first, but this way right here might be a little easier. Risers, and another view of it there. Go ahead and put a couple of more support boards in. And these braces here are critical. They're going to hold this together, and you might actually need to put a couple of them over here. If you think it's going to be weak, it wouldn't be a bad idea to put another brace in. And that can always be done after the stairway is built. But, while you're building it and you get to a certain point, and you're not going to be able to get to it from the back. Even like this point here would be good. You could come in here and just put a brace in here, or have it come up a little bit. Let's move it back there. You could have it come from here down. This would kind of be in the middle. So it would start up here and then go down to here, and that would stiffen this up. But as you nail everything together, you're going to see that these boards and these boards here are going to strengthen everything up. You're going to have a nice connection here. You're going to be nailing or screwing into the braces, or through the braces here into the other sideboards here. I'm going to show you more on the nailing here at the end of the video, give you an idea. And again, if you have any questions, feel free to leave them in the comment area. I know that when I'm building this stuff and on the computer, I can see, okay, this is a problem, like I'm doing here. I didn't put the riser in here because I need to be able to get this top support brace in. I need to be able to attach the brace to these side boards here. So you can see here, if I put this board on, I could still get to it, but I'm not going to be able to get to it if I put the top treads on. So you could always put the riser on here, as long as you're going to be able to have enough room to access some of these other spots, and then simply cap it off, and you are done. But don't turn the video off yet. Let's take a look at how we would nail or attach these. You can use nails or screws, whatever you feel is going to work best, and simply nail. And I don't think one nail is going to be enough for a 2x4. You're probably going to need 2 nails. Center them on the where you're going to be nailing into these boards below it, and maybe about 1 inch or 3/4 from the edge. And if it splits, pull the nail out and move it over a little bit. And then, of course, you can nail down the front of this to connect these two boards together. And the risers, again, 2 nails. And then the brace, you can use 1 nail per board, or you can use 2 nails per board, or use 2 nails, 1 nail, 2 nails, whatever you feel, or screws. And of course, you can always nail the back of the riser into this tread to create a stronger step. Without these nails here, you might not have a very strong step. And if you're worried about this one here, this one's going to be sitting on top of here. And then you're going to be screwing this. You're going to be making this one here a little stronger, but this one here in the middle might not be stronger. You might need to put a board on the bottom of this and screw it from the top, or screw it from the bottom, or even a couple of support braces in there to get a little stronger connection. And again, if you have any questions about that, feel free to leave them in the comment area. That is it for the video. And something like this seems like it would work. If you do build something like this and it's not working, it doesn't work out, let us know what you're having a problem with. A lot of times I'll draw something on the computer. And this is something I've never built before physically. I just kind of trying to help somebody out in another country who can't get larger pieces of wood. You might have to work with something like this. And in order to work with something like this, you might have to modify it, in a certain way. And again, I have 2 kind of braces here, and this is a 3-foot wide stairway. And like I said, if this right here is going to be a little loose, you could always put another one of these support side stringers, let's say, in the middle. And you would use 3 of these, and that would take the place of 3 stringers. And then, of course, that would really make it a lot stronger. Here's another one of those stair building tips that I used all the time to lay out accurate stair stringers. And accurate stair stringers are usually going to have level treads or level steps. They won't be leaning a little forward or leaning a little backwards, because you're not going to be rounding off the decimal. You're going to be using the decimal to lay out the stair stringers within a 32nd of an inch. And if you're going to be building a set of stairs with more than 15 steps, you might consider taking it up to the next step, which would be a 64th of an inch. And if I zoom in on the framing square here, you can see where we have 2 different markings for our fractions. In this one here, it's divided into an 1/8 of an inch. In this one here, it's divided into a 1/16 of an inch. And if this is a side you're dealing with on your framing square, then it might be a little bit more difficult. But I usually just divide this into sections. So if I was to go in between the middle here, I would have a 1/16 of an inch. If I split that in half, then I'm going to have a 32nd of an inch. And if I'm dealing with the 1/16 of an inch increments on the framing square, I just need to divide that in half. So for example, if 16 32nds is a half of an inch and I needed 17 32nds of an inch, I'm simply going to make sure that the center of this area right here lines up with the edge of the lumber that I'm trying to lay out the stair stringer on. And that will look something like this. Here's the edge of the stringer here, and here's the mark that represents the 32nd of an inch past the 1/2 inch mark, or 6 and 17 32nds of an inch. And right in between the 1/16 of an inch mark I was referencing to in the previous pictures. So here we have a 1/2 inch, 1/4 of an inch, 1/2 of a 1/2 inch, 1/4 inch. 1/2 of a 1/4 of an inch is going to be an 1/8 of an inch. 1/2 of an 1/8 of an inch. In between these 2 lines here, I'm going to end up with a 1/16 of an inch. And then if I go in between the 2 lines that represent a 1/16 of an inch, I'm going to end up with a 32nd of an inch. So not that difficult to do on a framing square. using the 1/16 of an inch measurement lines. So the moral to this story is simply start rounding your numbers up or down to the nearest 32nd of an inch and not the nearest 1/8 or 1/4 of an inch. Here is another video that is going to be another attempt of mine to make the process of building stairs a little easier. And I think that this right here just might make the biggest difference for those of you who are trying to build a set of stairs with a landing. Now also don't forget to check out our book and our book packages on how to build stairs with landings. And of course, the book package deal, definitely recommend getting the double book package with the laying out the stringers. Definitely going to help. It'll explain how all of the stringers are connected, what's going to be the best way to make the connection for the type of design that you are going to be working with. So let's go ahead and get started here. Take a quick tour around here. The upper stairs is located over here on our floor plan. Lower stairs over here. Here's the landing. Another view of it there. And the reason that this is going to be helpful for people who are having a difficult time, and I hate to say this, I have seen a lot of people who build stairs and they know what they're doing. Got a pretty good idea, and they still would be better off if they actually snapped all of these lines or drew these lines on top of the building foundation or the floor sheathing. I cannot tell you, because you can use these lines as reference points to double check everything while you're building. So that is the key to this video. Putting a floor plan type diagram on the floor where the stairs are going to be located. And hopefully by the time you're done watching the video, it will all make sense to you. So top of the top view of the stairway, upper stringers, upper steps, and this would be the upper section over here. Now the floor plan, if you're working with an architect or a building designer, it's going to have an arrow showing which direction that the stair travel is going to be. So it might have an arrow and it'll say up on the lower floor plan. And then it'll have an arrow pointing down on the upper floor plan to give you a idea where the stairs are and how they are functioning on that particular plan. Now let's take a look at what it would look like with the floor plan drawing underneath the stairs. We can see where the front of the stair riser here lines up perfectly with the line here. Go around, we have the landing here. So all of these lines are going to line up here. Very important. Now for those of you who just aren't quite grasping the idea why in the heck this floor plan is so important, let me see if this makes sense. I'm going to go ahead and draw some boxes in here. The boxes will represent the step. This is the top of the step here. The other side is going to be the front of the riser. Now remember that the front of the riser is going to be the face of the riser. This might not represent the face of the stringer or the notch you're going to cut in the stringer. This is going to represent the front edge of the plywood or whatever materials you're going to use to create the front of your riser. So here we have the front of our riser and the top of our tread, and it needs to fit within this box in our layout. Now let's go ahead and throw another box in there. We can see here again, front of the riser, top of the tread, and this of course is the third step up. So the measurement, when you are done, when the stairway is completed, top of the tread is going to be here. Front of the riser, face of the riser is going to represent this area. If you're going to use 1/2 inch plywood, then on the stringer, before you put the plywood on, you're going to be able to double check these measurements, get a level, come up and see if the stair stringer is a 1/2 inch back for a 1/2 inch riser. If you're going to use a 3/4 inch riser, the stair stringer will need to be 3/4 of an inch back so that when you nail the 3/4 inch thick riser onto the stair stringer, the front of the plywood, front of the OSB, front of the riser, face of the riser is going to be line up with these lines. And of course, this is what it would look like if you had the stringers, front of the stringer lining up with these lines. You're going to nail your 3/4 inch thick plywood on top, and it's going to be sticking past. So again, this isn't difficult to do. Before you nail the stringer into place permanently, set the stringer in place, attach it with some screws maybe, and then grab a level and double check everything and see what position, make sure that all of these lines line up. And you might even benefit from, if the stair stringer was cut incorrectly, you'd be able to see it right here in the lines that you have. So if you snap 10-inch lines apart on the ground and you, for some reason, laid out your stair steps at 10 1/4 inches, you're going to see it right here. But that isn't going to be the case, is it? Because you now have a valuable tool here to figure out exactly where to position everything correctly, right? So we're not going to end up with that problem. Now, I did move this landing back a little bit. Let's go back. I moved it back 2 inches, you could see here. This is something, again, you're going to have to adjust. If you have a overhang for your stair treads, if you have an undercut for your risers or your steps, you're going to have to set this back 1 3/4 maybe, 2 inches to get everything to work out. So keep this in mind also for your landing. Just don't build it at 3 foot. That's one of the worst things you could do. You know, come in and, hey, you know what, my landing's got to be 3 foot. Well, it can be 3 foot as long as you have square risers, as long as you don't have any overhangs for the treads, any stair nosings. No nosings, no undercuts. Yes, then you can have it, build it at 3 foot. If not, then you're going to have to adjust and compensate for every single piece of material in your stairway to get it to turn out right. In this video, I am going to provide you with an example of what your stair stringers could look like if they were off by as little as 1/16 of an inch per riser. So let's just say that you figure out, you get the total rise of the height between the floors, the top of the first floor to the top of the second floor. You do the math and you come up with a fraction and you just kind of round it off to maybe 1/8 of an inch when you should have rounded it off to 1/16 of an inch. So hopefully this will make more sense of what actually happens to the stairway by the time you're done with the video. So what I'm going to start with are 3 different stringers. This stringer here has a 7.5 inch riser height, individual riser height. Each individual riser is 7.5 inches. This one is going to be 1/16 of an inch larger, 7 9/16. This one here is going to be 1/16 of an inch larger than this one, 7 5/8. So we got 3 different stringers and the same length. And I'm actually going to use the center stringer for our experiment. So this line right here lines up with the center stringer, and the top of the floor is going to be lining up with the center stringer. So here we can see where there is a difference. There are 7 risers. So we actually have 7/16 of an inch, almost a 1/2 inch. 8/16 of an inch is a 1/2 inch. So this one here that is a little taller is going to be, or has the risers that are a little taller, is going to be a little taller. And this one here, of course, is going to be a little smaller. But without you knowing what's going on, you're going to end up taking the stair stringer and nailing it to the top of a ledger or the top of a floor like this. And actually, you're going to end up with a gap at the top of this one, and you're going to end up with a gap at the bottom of this one. We can see the gap here because now we are at two different angles. So each one of these risers, each one of these stair stringers has a different angle. The one that is 7.5 inches is 37.5. This one here, the center one, 37.1. And then this one here, 36.9. So just kind of remember those measurements. I'll remind them again later when I bring up another point when I go to longer stringers. So here we have a gap at the front, and it's tight at the back of this one. Another view of it there. Hopefully that makes sense. And of course it does with the angle, if you think about the angle. And you can also see that this, even though we haven't changed our tread measurements, these are exactly 10 inches. It's going to push this out a little bit. Now, when I'm saying this, these are computer aided drawings, and they're usually not wrong. And this is something I remember running into on job sites. If I didn't cut the stringer the right height, the risers didn't figure them out correctly. Precisely, exactly precise measurements for the risers. They've got to be, if this comes to, like I said here, if this is 7.5 inches and, or 7 9/16 is the measurement you should be using, but you use 7.5 inches, you're going to end up with this. And you're going to be wondering, why in the heck is this thing off? I think I checked this and it was off, I want to say almost a ½ inch. I think I checked. I think we'll have a measurement on that in a little bit. Now, of course, here we have a gap on the back of this one. So the gap on the front of the other one, the one with a 7.5 inch rise, we have a gap in the back. And of course, this is what you're going to be looking for. You set your stringers in and you have a gap in the front or the back. Grab the level, check the treads, and see if they're actually level, or if there's a problem with your calculations on your individual riser heights, and you might have made a mistake when you were laying it out. Either way, you make a mistake through the math, or you make a mistake when you figure the total rise, or you make a mistake when you are laying out the stair stringers. This could be a problem. Now I went ahead and I drew a level line, and this I believe was about a 1/16 of an inch. But if we level a line across this one here is going to be level. This is what we figured the height, and everything works out correctly for the center stringer. This one here, the stair treads are going to be leaning forward. The one on the other side is going to be leaning backwards. So again, this isn't difficult to figure out. You put the level on here, you're out of whack, something's not right, double check all your measurements. Now this is where I actually learned something. I thought that these measurements would have changed. It's still about a 1/16 of an inch here, sloping backwards. And of course, this is a longer stairway. The degrees of these stair stringers have not changed at all. And if you think about it, they shouldn't have. It's the same rise and the same tread height, just multiplied by this many more stringers. So this, treads and risers, this stringer could have 100 steps on it and it would still be at the same angle. All three of these would be at the same angle if you were working in this particular instance. However, the measurement on the bottom is going to grow a little longer, and I really don't know why that is, but I checked the other one. And this one here that's 9/16 of an inch, on the one with only 7 risers, it was 1/4 of an inch. So this actually grew a little larger here, even though the angle hasn't changed, and we still have the same gap. And if you know the reason why that changed, or if I made a mistake with my drawings here or my computer-aided software, feel free to let us know. I am always open to any constructive criticism, as long as it's constructive. Let's not get carried away. But the gap didn't seem to change here. So realistically, on the longer stairway, we still have the same angle. We just have a little variation, a little more at the bottom than we would if it was a shorter stairway. And I can't really wrap my mind around the reason why that would be, just that it actually showed up in the drawing. So that is it for the video. If when you're laying your stair stringers out and you're especially on a longer stairway, this isn't obviously going to be a bigger problem on a longer stairway if it's going to be the same angle. But if you want your stair treads to be as level as possible, make sure that you lay your stair stringers out to possibly within a 32nd of an inch, if that's what it's going to take to create a nice level stair step for the entire stairway.